This project on network intrusion detection using machine learning and big data analytics is a way for us to spot cyber attacks hidden in massive network traffic. I'll explain what I did, what I found, and how this can strengthen network security. Why did I choose this project? Well, because cyber attacks keep getting more and more advanced and harder to detect. I wanted to see how data science could help automate detection instead of relying only on traditional defenses. Using PySpark also let me test how big data tools can handle real world traffic size efficiently. Firstly, when we have efficient practices, we have effective practices.
We used the CIC IDS 2017 dataset from the Canadian Institute for Cybersecurity, a standard for testing intrusion detection systems. Studies show that random forest often performs the best, while isolation forest helps catch new, unseen attacks. And our goal was to test both approaches on large-scale network data. Problem was clear, to detect malicious traffic hidden in millions of normal connections. And some challenges include processing huge data, keeping false positives low, as well as detecting known and unknown attack behaviors. So we wanted to see which methods handled these challenges the best.
With big data techniques, used Apache Spark with PySpark to clean and process millions of data points, where millions of network flow records were merged, cleaned, and standardized. Spark let me scale up easily and run tasks much faster than standard tools, where it allowed distributed computation and demonstrated that scalability efficiency that we needed for pre-processing pipelines for everything involved. And this setup shows how intrusion detection can work at an enterprise scale. Okay? Next, we move to the machine learning models. And I compare two models, random forest and isolation forest, where random forest is supervised. It learns from label attack data and gives good, accurate accuracy. Okay? Isolation forest is unsupervised. It looks for anomalies even if they've never been seen before, which is out of the ordinary. Okay? And with both of these, just different models, but comparatively have their purposes. And together, they cover both known and new attack types. And these were important for our project.
To the result of our study, we adopted metrics such as accuracy, precision, recall, F1 score, and the AUC, and also the runtime. We found that for random forest, which is a supervised model for our study, performed better than its counterpart, the isolation forest, which is a non-supervised model. The random forest had the least performance, which is the precision at 93%. Every other metric had above 93% for random forest. For isolation forest, we had as low as 80% for the precision, with the accuracy being 87.5%. Area under the curve 90%, which is the only metric that hits 90%. Now, when you compare the performance of these two models, based on all metrics used, we discovered that random forest performed better than isolation forest. Since random forest is the better out of these two models, we decided to check what are the features that aid it in having this high accuracy. We discovered that features like flow duration, total packet, average packet size, up until the packet rate helped in the prediction. And these are the top 10, like seen on my screen, features that were important to that model. However, the flow duration, the total packet, and the average packet size were the top 3 most important features that the random forest model used for its prediction.
To recap our findings, Random Forest performed very well on the labeled CIC IDS 2017 dataset, giving high accuracy and recall for known attacks. Isolation Forest wasn't as precise, but it was useful for catching unusual or unseen behaviors, which makes it a good complementary detection tool. Using PySpark was important because it let us process millions of flow records efficiently. And if this were deployed in a real environment, a streaming setup like Spark Streaming or Kafka would be needed to handle real-time traffic. There are challenges on both cybersecurity and data science sides. For cybersecurity, the biggest issues are dataset drifting, adversarial evasion, and class imbalance. Real-world traffic changes constantly, which makes detection harder. From the data science side, we deal with feature selection, labeling large data sets, and reducing false positives, and making sure the models scale. For future work, the main areas to focus on would be ensemble methods, better model calibration, and moving these models into a real-time streaming environment.
In conclusion, throughout our project, what we learned is integrating PySpark and machine learning provides effective intrusion detection capabilities. What we used throughout the project, random forest and isolation forest. Random forest was leading to high accuracy for known attacks, and isolation forest was detecting novel anomalies. Future directions include improving real-time detection and minimizing false positives. And throughout the project, these were the references we used, and the main data set was the CIC IDS 2017 data set. And these references helped throughout the project for getting our cybersecurity results. Thank you.